The second derivative test says that you can use the second derivative, plug in a critical value into the second derivative, and if the sign of the second derivative comes out to be positive, I'll write that down, positive second derivative, tells us that we have a relative minimum at that point, at that x value, okay? So if you plug in a critical value into the second derivative, and this time get a negative second derivative, negative second derivative, that tells you that we have a relative maximum at that point, okay? So in the first section of chapter 3, we talked about using the first derivative test, like checking the sign to the left, sign to the right, using the first derivative. But this one is a little different, okay? I will show you an example of this, but remember, okay, let's remember that positive second derivative means we have a relative minimum, and negative second derivative means that we have a relative maximum at that x value. Now, if the second derivative doesn't come out to be positive or negative, like 0, because 0 is not positive or negative, right? Then the second derivative test does not work. You will have to go back and use the first derivative test to see if it's a relative minimum or maximum. So I'm going to come back and talk about concavity in another video, but go down, and let's look at this first example and try to find the coordinate of critical points and classify each point as relative maximum, a relative minimum, or neither, using what we just talked about on the second derivative test. So I'll make a note up here, okay? If you have positive second derivative, what does that mean? We're going to say, ooh, this is where relative minimum happens, okay? Now, if we get negative second derivative, what does that mean? We must have a relative maximum at that point. So you remember this. Okay, I'll put like a star next to it. Star. Okay, so let's find critical value. Okay, let's start with critical value. Find the first derivative. We get 3x squared plus 6x minus 9. And we're going to set this equal to 0 to find critical values. Notice 3, 6, and 9 are all divisible by 3. So you factor out the 3, okay? And this helps me. I like to put like what I'm dividing or what I'm factoring out underneath so that I can have a visual of what I'm dividing, okay? I'm going to put that 3 in front of the parenthesis, but let's see what's inside the parenthesis. I divide 3x squared by 3. That is x squared. Next, I divide 6x by 3. That is 2x. Lastly, I divide 9 by 3. That is 3. Now, this trinomial that I have inside, this is factorable. So keep that 0 equals 3. Well, let's break this down into two pieces. We can have x times x for the x squared. I can have 3 times 1 to get 3. But if I make this 3 a positive and 1 a negative, they will add up to positive 2. Because 3 minus 1 is 2. All right, I'm almost done finding critical values. Let's set each of these equal to 0. X plus 3 equals 0 when x is equal to negative 3. So we found the first critical value. The first critical value is x equals negative 3. The second critical value is the number that makes x minus 1 equal 0, and that number is x equals 1. Now, in the first section, we set up a number line to check the sign to the left, to the right, and in the middle of these two critical values. I'm going to use the second derivative test. You ready? We're going to find the second derivative and plug in these numbers. If it comes out to be positive, we're going to say that's where relative minimum happens. If it comes out to be negative, we're going to say that's where the relative maximum happens. So we will need to find the second derivative. Now notice that the first derivative was f prime equals 3x squared plus 6x minus 9. All right, I'm going to go and find the second derivative. Second derivative, f double prime, is 6x plus 6, right? Now, we're going to plug in these two critical values into this second derivative. So first, what is f, where do I want this f double prime? I'll put it right here. What is f double prime of negative 3? All right, let's see what we get. That is 6 times negative 3 plus 6. That's negative 18 plus 6. And that's negative 12. Look at that. That is a negative second derivative. Now, what is that? Is that minimum or maximum? Look. Negative second derivative tells us that we're looking at a relative maximum happening at x equals negative 3. So this is going to be relative max. All right. Similarly, I'm now going to plug in our second candidate. The other critical value that we have is positive 1. All right, let's see what we get when we plug in positive 1. 6 times 1 plus 6. That is 6 plus 6, and that is positive 12. Now, what does positive second derivative tells us? This is where relative minimum will happen. Okay? This problem wanted us to write critical points. So we will have to find their y values. All right. So what I'm going to do is I will find, because this is what we have so far. We have relative max is at negative 3, comma, blah. Like we don't know what the y value is just yet. And we have a relative minimum at positive 1, blah. I don't know what the y value is. So this is where we now use the original function. Copy down the original function down here to find their corresponding y values. Okay, so this is nothing more than just plugging in x into the function. So let me do that. What is f of negative 3 and f of 1? So negative 3 cubed plus 3 times negative 3 squared minus 9 times negative 3 minus 13. the next one, I'll do 1 cubed plus 3 times 1 squared minus 9 times 1 minus 13. And I would like to use a calculator for this. So over here, I was on a graphing calculator, but graphing calculators can evaluate this too. So I'll do that. Typing the first line. Minus 9 times negative 3 minus 13. So when I plugged in negative 3, the y value came out to be negative 40. So that must be the y coordinate. And now let me do another one. I'll just copy this. Oh, I think I made a typo. See, I think all of these have to be negative 3. I put a positive 3 there. Let me fix that. Okay, so not negative 40. Thank goodness I caught that mistake. But positive 14 is the y value. Now I'm going to copy this because I want to do another one, but this time with 1. Plugging in 1 as the x value. When I tap all those in, I got negative 18. All right, so let me go back over here, and I will fill in these blanks. When I plugged in negative 3, y value came out to be 14. When I plugged in positive 1, I got y value to be negative 18. This is my answer, but I'm going to now graph this since I have my graphing calculator open here to see if I got this right. So the function is f of x equals x cubed plus 3x squared minus 9x minus 13. So this is just me checking my answer, Zoom out over here. Let me see if I can show you all the graph. Oh, it's a very skinny graph. All right, I will click on the relative maximum. Look at that. We have a relative maximum at 3, negative 3, 14. Yay, we got that right. See? Negative 3, 14. Let's go click on that relative minimum. That is down here, which is at 1, negative 18. 1, negative 18. So we got it right. So this is how you can use the second derivative test to find if a critical point is a relative maximum or relative minimum.